All right, guys, so hopefully last week you did okay on the first part of chapter 17. If you did, this should be actually pretty easy. Now I'm going to struggle on this because my normal curve here is drawn pretty small. I actually think I'm going to flip to this screen, and as we fill in the normal curve, you would be filling in the one on your notes if you have your notes printed, and I'm going to be filling in one here because I have a little bit more space. So what we're doing is very similar to what we did last week. We're just adding one last piece and perfecting what we did so we can move on next week to what's called confidence intervals. So state police believe that 70% of the drivers traveling on a major interstate highway exceed the speed limit. So that means at any one point in time, if you pick out a car, there's a 70% chance that that car is actually exceeding the speed limit. They plan to set up a radar trap and check the speed of 80 cars. So instantly I can see the fact that in my sample size is going to be 80 cars. Using the, if you go way back to, a few months ago, we learned that if you have an average and everything's in a normal curve, that we learned that 68% of my data falls within one standard deviation of that. So one up or one down. And then 95% of my data falls within two standard deviations, which is these blue lines here, and then 99.7, so nearly all of my data is going to fall between three standard deviations. Let me turn my dishwasher off. Hold on. Sorry. So the first thing we have to be able to do with this information is we have to be able to find our standard deviation. Now, of the proportion here of what's going on. Now remember, at any point in time, we believe that we have a 70% chance of finding a car that is speeding, which means my failure would be not speeding, which is actually should be the opposite, but a 30% chance of finding a car that is not speeding. So when I go to find my standard deviation, I know I'm doing P times Q all over N, which in this case is 0.7 multiplied by 0.3, sorry for the messiness, I never got my pencil, all over 80. So if you guys would take a second and either pause this video or type that in your calculator to help find the standard deviation, make sure that you can do the same thing that I'm doing calculation-wise up here. So with a sample size of 80, I have an expectation that my standard deviation is 0.051. I'm always going to go 3 decimal places. The farther you go, the more accurate your data. So my standard deviation is 0.051, meaning that any sample size is going to vary on average by about 5.1%. So depending on if you find a sample of 80 cars, you have your standard on average. It varies, maybe it's going to be 75 or 65% of those cars are speeding. So as I go through to create my normal curve, it's going to help us answer C, D, and E. So my normal curve here, I would expect the fact that 70% of my cars are speeding. I'm going to keep that in black because that is my percentage that I'm expecting. Now back here I went red, blue, green, so I'm going to do the exact same thing. I'm going red, which is 1 standard deviation up, which is going to be my 68%. So you take your 0.7 and you add 0.051, which obviously will be 75.1. Sorry, that's what my phone sounds like all day long with people sending messages on Parent Square. So I'm going to, you know what I'm going to do? I'm just going to keep going up to make my number easier. I'm just going to keep adding 0.051 to save myself a little time. So this guy right here would be 0.802. And this guy right here, I'm going to add another, would be 0.853. Now, go back to your 0.7. 70%, and subtract your 0.051. That should get you, I'm going to write sideways, 0.649. Sorry, I will silence this guy here. My blue number here, I'm going to subtract another 0.051, which is 0.598. And subtract another 0.051 from my green, my 3 standard deviations below, which is 0.547. So to answer your B, C, and D, 68% of your data in these samples would fall here. If you had a sample of 80 cars, 95% of your data would fall here. And 99.7, darn near everything, would fall there. So if I go back here, my red is going to be 64.9 to 75.1. So 64.9% to 75.1%. My next one, my 95, would be 59.8 and 80.2. 59.8 and 80.2. And 99.9% of my data would fall between 54.7 and 85.3. 54.7 and 85.3. Now the last and final question here is, would you be surprised if police found that 42 out of 80 cars were speeding? So let's figure that out. This is going to be my P hat. 42 out of 80. And you can't just say, yep, I'd be surprised. You got to show me your calculations. So this is 0.525. Now here's where my normal CDF curve is going to come in. So remember, I'm going to go back to my picture here, 0.525. I'm going to put it in yellow. 0.525 would fall here, way over here. So I'm going to go and shade this way. You technically could shade either way as long as your answer is right at the end. I'm going to shade this way, and I'm going to go, that's my low bound. I'm going to go all the way up here, this huge number for my up bound. So you got to find your z-score. Your z-score is going to be, take your p hat, which was your 52.5. I think that's, yep. You take your 52.5, subtract out what you were expecting to get, which is 70%, and divide by your standard deviation, which is 0.051. So take your 52.5, subtract out your 0.7, and divide by 0.051, which gives you a z-score of negative 3.43, meaning you are almost 3.5 standard deviations below the mean. So if I do my normal CDF curve, so what you're going to type in your calculator is you're going to do a normal CDF. Your low bound is going to be negative 3.43. You're not going to have a high bound because you're going to go way, 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 way to the right. So it's your huge number. So you're figuring out what percentage is below this curve here. So pause the video if you need to. Type that in, your normal CDF, negative 3.43. Remember, your upper bound is this huge number, 99999. And what I got was 99.96% of my samples would have more than 52.5% of my cars were speeding. So at the end of the day, if I have to write a sentence, would you be surprised if police found that 42 out of 80 cars were speeding? Yes, I would be surprised, because 99% of the time, a higher percentage of cars is speeding than that out of the 80. Hope that helps. I'm going to do problem number 2, and I'm going to ask you guys to do 3 and 4 on your own, or meet with me on the Google Meet to complete those questions.